Okay, friends and neighbors, time for another networking video. Today we're going to use Packet Tracer to help us out with a couple of ideas that are part of access control lists. And really, access control lists are part of a larger idea too. So the two things that we're going to look at in Packet Tracer today are containers, the idea of a collection of addresses or ports, and then the idea of match criteria. And we'll do more of these, but that's how we're going to start today. So the first thing we'll do is we'll build a small topology, and maybe we'll just add some of our switches and routers. Go ahead and connect them here. Oops. I suppose it'd help if I selected a kind of connector. There we go. All right, like that, and I'm going to add a couple of hosts to each side, and actually we'll get away with just 1 and 1 for right now, just to get us the idea. Oops, I did it again. Here we go. We'll connect you to port 1, maybe you to port 2. And then we'll do this other side over here too. Now, as you can see, we've got a couple of PCs, and they're on the opposite sides of a router. So we've got to configure our router. I'm going to make life a little easy on myself here, and we'll just go with the 192.168 1.0 and 2.0 networks. Do it like this. And hopefully y'all can read this. Now I am going to use /24s on this also to make life a little easier so that we don't have to think too hard. But that won't take away from, sort of some of the ideas. Okay, so hopefully these should be starting to come up. They are. And I've got to give my host some addresses here. And also on the one net here, we'll do your gateway. Okay, good. Now the reason I'm putting 2 on one side and 1 on the other is because I want to show you how we can or what's required to actually put nodes together when we start talking about containers, and how we might separate them, and actually how ACLs actually work. So let me just get done with this here. Almost done. And in 10, 9, 8, 7, 6. Oh, I missed it. 5, 4, 3, 2, 1. All right, so we'll see if we can ping around here. So first I will try to ping my neighbor on the same network. That looks good. And then we'll try to get across to the other side. And we'll let our ARP tables update, as the router figures things out. So a lot of times the first one will time out. There we go. All right. So now we have our small operating network here. And what I'm going to do now is go onto the router, and I'm going to make, let me do this too. Let's shift things around a little bit so that a little more compact, a little easier to see what's happening. Okay. And now we'll bring our CLI back up here. Okay. Now, access control lists are one of the first places that we learn about the idea of containers. We're trying to control traffic. But actually, the core idea there is that first we start off with this container before we ever start controlling traffic. And the reason for that is that containers can be used for anything. Now, containers come to us in the form of an access control list. And an access control list is just that. It's just a list. It's a list of things that we want to be considered together in the same list. So I might say access list, I don't know, 5. And then if we just use our help system here, we can say, oh, well, what do you want to do with this particular access list? Now, I am going to use it to permit something. And we can see that we've got a couple of options here. An address to match. All right, so that also brings up our first idea here, or at least our first time that we're seeing the word match. And match in this case is referring to a match criteria. And so that is to say that I want to figure out how to match a particular address. So I might say any, so there's a couple of ways that we can do this, but let's say that if I was going to talk about a network, I might do this. I might say 168.1.0, right? And then I might say, oh, I got these weird masks now. Now, if I take a look at this, there's wildcard bits. That is how we refer to masks. And so I'm going to do this sort of weird mask for you here. And that's because a lot of times we think of ACLs sort of backwards from subnet masking. So that is my first match criteria. And what is this match criteria saying? It's saying that in this access list, this container, I want you to permit anybody from this particular network. Now, before we go too far with this, access list masks or wildcard bits are very similar to OSPF and some routing protocol masks in that they look opposite. Now, a lot of modern routers or modern equipment will allow you to use the same kind of masking that you use in subnetting, but we're going to use what you probably have a good chance of running into. So how does this work? Well, let's start with networking to begin with. So if I say that I have a network that looks like that and I have a mask that looks like this, then what I might say is that all of these networks, or this particular mask and network combination matches all of the following addresses from 1.0 to 192, 1.255. All of those addresses are matched by that combination. And so my match criteria then is really this network address and this mask. And so the match criteria here matches these 256 possible addresses. In masking for ACLs or access control lists, I find a very similar sort of idea. Let's do this. But I'm going to do sort of the opposite. And so this mask matches the same thing. Okay. Now, things can get a little interesting here. So what we have to realize is that in subnet masking, what am I paying attention to? I'm paying attention to where the ones are in the mask. And over here, what do I care about? I'm paying attention to where the zeros are. And so that changes things a little bit. That changes how I think about what is matching. And that's why we say a lot of times that ACLs are opposite from the match criteria or the masking that we see in subnets or supernets or CIDR. So this also means that if I wanted to change my criteria, I would say, well, what if I actually ended up doing a subnet or two? What if I did these subnets? The 1.0/25 and the 192.168.1.128/25. That's just splitting that network, that class full, class C network, into two halves, right? So that's what we've done. So what would be the corresponding ACL mask? Well, let's remember that in this case, my subnet mask would look like this. Okay, so I've extended the ones into the subnet portion. Well, over here, if I wanted to do the same thing, if I wanted this to match and I wanted this collection, right, then, and we might as well put them both down on the side, right? If I want these guys here, then the ACL that I would have to use would have to extend the zeros into the host portion. Well, what does that look like? Well, if I have all ones like I had before, right? And well, let's go ahead and shift to the binary. So 1, 2, 3, 4, 5, 6, 7, 8. Well, what this would have to do is shift to this. 5, 6, 7. So make sure I got the right number here. 1, 2, 3, 4, 5, 6, 7, 8. Very good. Okay. And so that means that now my access control list would look like this. Well, what is 0 followed by 7 ones? It turns out is this. Okay. Oh, whoops. It turns out it's not that. It's actually this. So that's what it would actually look to be. So, and the way that this, you just count this is just in binary, right? It's just 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 63. Add all those up together, you get 127. Okay, well, there's another part to this, because it's not just getting the match right. So if I was to say, let's continue down our columns a little bit. If I said to you, I have this, and then that mask, what would be the range of IP addresses? Well, the range of IP addresses that would match that would be from 0 to 127. And if I had the exact same thing, but I changed this part right here, if I change the first argument right there, what does it now match? Well, now it matches 128 to 255. So the important thing to realize here is that it's not just the mask. It is also what we have up front here. Together, those two things constitute the match criteria. So that's really, really important. Now this right here, whatever it is, whatever you put in your rule, well, that is the container. So let's go back now to our CLI. And this is really nice. I created this, and by now you've probably figured out that with this match criteria, with this part right here, with this part, you're not going to do it for me, this guy right here, that prefix and this suffix, or that first argument and that second argument, that the addresses that are matched by this are 0 to 255, right? But what am I doing with them? Oh, well, in this case, I'm permitting them. Okay, great. Permitting them where? Now, I could have denied them as well, but where am I permitting them? Well, it turns out that access control lists there's actually a two-part thing that you have to do. The first thing is you have to create your container. And then the next thing that you have to do is apply them in an interface and direction. So we're going to do this two ways. So let me minimize this guy here. Okay. We're going to take a look at, we're going to go to this interface right there. So that's F0/0. And now I've got this access list out there. So now I'm going to say IP access group 5. I have to identify it. And I will say in. Okay. So if I go show access lists, right? That's my access list. I don't recall putting it, all right. It's interesting. Okay, so here's a better way to see it. Here is my access group 5 applied in, right? And that's the set of rules that I have in my container. Now what this means is that all traffic coming in to this interface that's in this particular direction, right? Directionality is a really important idea. All traffic going in that particular direction now is going to be tested against this rule. And if it passes, if it matches this criteria, then we say, okay, what do you want to do with it? Well, we're then going to permit it. So let's see if it works. So I'll take this guy here, and I will say, I'm going to ping somebody on the other side. Now, if I ping somebody on my side, it never hits the router because I processed my host routing table and I never need the router. But let's see if this works. And it does work. So that's fabulous. That's fabulous. All right. So now it turns out that I can have more than one set of rules in my access list. So I am going to, we're going to get rid of that access list. I'm going to go to int f0/. So I'm not going to get rid of the access list. I'm just going to remove it from, oops, let's see, where are you? There you go. I'm going to remove it from the interface. No IP access group 5 in. And so to see what we just did there, right, it's just now a normal interface. So now let's go access list, I don't know, we'll do 5 or 6 this time. Permit 192.168.1.1. Okay. Now, if I want to match this particular host, then what I want to do is create a mask that identifies all of this host address. Now, there's a couple ways to do that. I can do it with the keyword host, or I can do it with wildcard bits. So we'll do it with wildcard bits. Okay. And then what I'm going to do is go to int f0/0, and I will say IP access group 6 in. Now we'll see what the impact of this was. Now what my access list does is looks at the traffic going into the interface. So I'm going to try this ping. That works. But now I'm going to go over here to this guy, this other PC, and I'm going to try the same thing. Uh-oh. So my router just said, oh, no, you don't. And why did the router do that? Well, the router didn't allow that traffic through because this host was not part of that access list. Now I can fix that. But I want to point out a couple of things here first. One is that one of the things that's part of every access list is an implicit deny all. So what you can imagine right here is that in addition to this access list, so if I come over here, oops, there we are. If I come over here and I said this, no, it didn't work. I was hoping I could cut and paste between them. Access lists, whoops, 6 permit 192.168.1.1. That, right? Right after that, there's also this, which we do not see. Okay. And what that means is that if you're not permitted by a permit statement, then you're denied. So if we want traffic through, we have to permit it. So let's do that right now. So I'm going to go into access list. Now, one of the problems with a lot of routers is that the minute I start to edit this, it actually goes away. So I'm going to do that statement, and then I'm going to do that one just to make sure that they're both there. And then we'll show you what we did. Okay, so there they are. They're part of the same access list. My access list is still applied. So theoretically, if I go over here to this host, and we'll just make sure that we have the right host, right? Make sure we don't have any funny business going on. So this is 1.2, and I'll try to ping 2.1, and hey, look at that. It just worked. Okay, so that's how you would fix that. That's how we have to deal with an implicit deny all. Now this is just ICMP traffic, and these are just what we call standard ACLs. So nothing really crazy, nothing really special. I am going to show you one more thing before I leave you today, and that is this. Let's go to our interface again, and here's our access list. I'm going to remove the access group from the interface, but then I'm going to apply it again. But this time I'm going to apply it in the out direction. IP access group 6 out, like that. Okay, so just to see what that looks like, right? So now it's in the out direction. So let me see if I can draw that on here. Do we have a, I can't remember. Hey, drawing palette. Let's try this. So that is traffic heading in that direction. That's where we are right now. It's traffic coming out of the F0/0 interface. So let's go to our friend here, and we'll try the same ping. And all of a sudden it doesn't work. Well, why did that happen? Why was that? We have to remember our match criteria now. So this doesn't work. I know. Let's make sure, and we will test from the other PC. That doesn't work either. Here's what happened. When I have this access group applied to the out direction, it turns out that standard access lists, these guys here, these are source IP addresses. And so if that source IP address does not appear coming out of that interface, then it fails. So let's think about this for a sec. In a ping from PC0 or PC1 to PC2, it goes across the router like this and goes into F0/0 and out of F0/1. In both of those cases, the source IP address would have been 1.1 or 1.2. But on the return trip, the source IP address is 2.1. The destination is 1.1 or 1.2. So when the test comes for the match criteria, they both fail because the source IP address is going to be PC2 or 192.168.2.1. Well, I think that'll do it for this particular video. I hope I helped, and I hope this keeps you moving along the way of networking success, and may your packets always reach their destination as always. But remember, this is networking. You can do this.